Hello, good evening, everyone. I hope you are doing well. I'm doing fantastic. So this is just the video that, let me pull this up over here so it'll be much more easier. So this is just the continuation of the post that I posted on my website. And on this particular video, I'm just trying to explain why Lasso works as a variable selection, but Riz doesn't, or why Lasso regularization also works as a variable selection in the model. So we have seen that, I think you have seen that plot, the contour plot uh, with the constant function, constant cost function, as well as the penalty term in my website. And that's the general way people explain, but this is just a different way of seeing the things, like just going more into a little bit more into mathematical aspect of those things. So here on my screen, as you can see, is the cost function for the ridge regression as we are familiar with. Now for the simplicity, let's just suppose we have a one observation or one instance and we just have only one variable, just for the simplicity. Okay, so now the equation is going to change a little bit if I assume those things. So it's going to look like y minus theta naught minus theta 1 x, and gonna be square equals to lambda, oh sorry, this gonna be plus lambda theta 1 whole square. Okay, because we are just taking only one instance or one observation with only one features. Okay, just for simplicity. So let's open up that equation, okay? And just for more simplicity, I'm gonna assume let my y minus theta naught equals to m, okay? I'm just gonna assume that thing. So now how does the equation gonna change? It's gonna change like this: m minus theta 1 x whole square plus lambda theta 1 whole square. Okay, I'm gonna open that equation because it's a minus b whole square. So I'm gonna open up that with that expression. So it's gonna look like m square minus 2 into m into theta 1 x plus theta 1 whole square x whole square plus the lambda theta 1 whole square remains the same. Now let's just gonna let me try to theta 1 x plus theta 1 lambda theta 1 whole square. That's just we open up. Now this is our cost function. In our objective is to minimize the cost function, and how we can minimize is that we can take derivative. We can take derivative and we can equalize to 0 to get the minimum value of derivative with respect to whatever value we are taking, on which the cost function will be minimum. So since our objective is finding the theta 1 or beta 1, the same thing, so what we're going to do is we're going to take derivative, or maybe partial derivative, with respect to theta 1. Okay, so now how does that gonna change? Now here we know that m square is y minus beta naught. They both are constant. So if you take the derivative of a constant, it will become to 0. So we can directly write that as 0 minus, now the derivative of this second term, which is 2m theta 1 x, I change the color, this 2m theta 1 x will become 2 m x, because in the theta 1 with respect to theta 1 will give us 1. Then again the derivative of the third term, we will get plus x square is a constant dot 2 theta 1, and the derivative of this last term we will get as 2 lambda theta 1. Okay, let's just try to make it a little bit tidier. 2mx plus 2x squared theta 1 plus 2 lambda theta 1. So that looks much neat. Now, as we say, taking derivative, then equalizing to 0. So let's just equalize this part with the 0, then we're going to change the size a little bit here with, and we're going to cancel out these two because they are the same coefficient in each terms. Then we're going to get something like this. So it's going to look like theta 1 equals to mx divided by x square plus lambda. Pause that video if you didn't get that, but it should be fairly easy for you. Now here comes the thing. As we mentioned, this is for ridge regression. Don't forget, this is for ridge regression or ridge regularization. So now, as we said, mentioned in ridge, we cannot make our coefficients theta, beta, these terms to 0. We can get closer to 0, but cannot make it to 0. And that's the answer, as you are seeing the answer in front of you. So if I ask you to make that theta 1 on this equation, if I ask you make that theta 1 equals to 0 by changing the lambda, how are you going to do? To make that whole term 0, but there is only one way. The one way is if your lambda tends to infinite. Now, is this possible? No, we don't do lambda equals to infinite, or it's not practical. We can get lambda to a higher value, but as the lambda values increases, your theta 1 will goes to closer and closer to 0, but it will never become 0 because lambda can never reach infinite. So that's the whole point here. Since we cannot make our lambda hyperparameter infinite, that's why in ridge regression, you cannot make your coefficients or weights equals to 0. Now let's look the same thing or in the same way for the lasso regression. Okay, so I'm going to scroll down. I already have written this cost function for a lasso regression, as you can see here. Everything else is same, just that instead of a square on the penalty term, we have absolute sign, also called L1 regularization. So now let's do the same thing for just one observation in one feature. Okay, then my function gonna look like y minus theta naught. This would be theta naught minus theta 1 x whole square plus lambda theta 1. Okay, and let's suppose my theta 1 is positive, and it will become positive because of the absolute sign. Now let's do the same thing. Let's assume y minus theta naught equals to m. Then we will see how it's gonna change. Is it's gonna become m minus theta 1 x whole square plus lambda theta 1. Let me scroll down a little bit. Now we're gonna do the same thing as we did previous. It's gonna look like m square minus 2m theta 1 x plus theta 1 whole square x square plus just lambda. Okay, and I'm also going to equalize to 0 because again we are doing the taking. Let's skip this for a second. Let's just rearrange this equation a little bit. Now I'm going to do again derivative, the same thing. Okay, derivative, let's do partial with respect to theta 1. Okay, now the derivative again, the m square, as we know, there is nothing beta 1 component on that variable, so it's going to go to 0. Then it's going to look like 0 minus 2mx plus x squared dot 2 theta 1 plus, sorry, I missed the lambda over here, my bad, here on this component, plus lambda. Then I'm also going to equalize to 0 because taking the derivative and then equalizing to 0 to find the beta 1 when the cost function is minimum. So rearrange those things a little bit. What I'm going to get here is x squared dot 2 theta 1 equals to 2mx minus lambda. Then my theta 1 equals to 2mx minus lambda divided by 2x squared. Okay, now this is for our lasso regularization. Okay, now if I again ask the same question that I asked you previously and asked you that, can you make the θ1 value 0 by changing the lambda? And the only way you can change it, if somehow your lambda value is equals to 2mx, then you can get θ1 equals 0, because 0 by something will become 0. Now it's a possibility because 2mx, and we know that from our previous, it's 2y minus theta naught x minus lambda. So now this term, which is 2mx, this is a finite term, meaning this came from a training data set. This is a finite term. So first, those variables where your lambda is equals to that 2mx term, that will make that θ1 equals to 0. So this is the answer. As we saw in the ridge regression, it wasn't possible. The only possibility for ridge regression that we saw previously was whenever your lambda will become infinite, which is not possible. But for here, lambda don't have to be infinite. It could be any finite number that equalizes to mx, then it will make that whole θ1 equals to 0. So this is the intuition behind why Lasso is able to do the variable selection and why Riz is not able to do the variable selection. So those are the things that I want to tell you through this video. I'm going to also attach the Stack Exchange post that inspired me, and that's how I learned about this thing. And I'm going to attach that into the comment section or a description section. Check that out also. And I'm also going to attach the basic concept about the regularization that I posted on my website. So check that out also. So yeah, those are the things. If you have anything, any feedbacks and suggestions are appreciated. You can put it in the comments. And yeah, I hope now it makes sense to you, like why Lasso does the variables selection and why Ridge doesn't do that. Thank you so much. Have a great night ahead. Take care. Bye-bye.